Hello and welcome back to a new video here on the Ludwig Fusel channel. Now this again is rather an odd video because it really doesn't fit into what I'm currently doing, and there are actually multiple reasons of that. First of all, I'm working on this project because I try to actually use it and convince some people that it's actually better to do it the way that I am currently doing it, or trying to convince them for the benefit of doing it as I trying to do it here. And the other thing is I don't have my videos ready. I actually intended to prepare a few videos on the game engine series before I'm getting on holidays to Italy. However, I changed my computer. I moved to a new chassis. I put all the components in a new chassis. I kept my hard drives. I kept my GPU. However, I going to a new CPU system and new RAM technologies and the whole different system. I was going from AMD now back to Intel, while I've came from Intel to AMD the first place, but now I'm back on Intel. It's like a mini case. It's actually on my desk. It's the smallest form factor that you can get. It's getting super hot in there if I'm starting to play video games, but this was all intended because I wanted to see how far you can actually push it. But that's a different story. The story why the videos are already is I put them on the wrong hard drives. I actually intended to put my videos on the SSD, or I always thought that my videos were on the SSD. And I intended to swap the whole SSD. I have two standard SSDs in there, not M2, not of this fancy stuff. And I thought one of these is my video SSD. And then I moved to the new chassis. I've put the SSD on there, booted the system up. Surprise, surprise. The SSDs were not the ones with the videos. It's actually my old HDD. However, as I told you, I have a small case. There is no space for a big old classic HDD. So I currently have a problem that I'm not getting access to the videos. The videos are not lost. They are on the hard drive, and I've ordered an adapter so that I can plug the hard drive in there and then plug it in via USB to get the video files off there. However, shippings, Christmas, it's a bit odd. I'm not going to be able to have this ready for my holidays in Italy. So what I'm trying to do is I'm trying to give you a devlog style. And if you like these videos, we actually can continue because it's a project that I am gonna work on for longer. As I told you, I am trying to convince people that this is the way on how it should be done. If this gets approved and they say, all right, the maintenance effort of a big system written in C++ is worth it, then I'm gonna completely develop the system out of everything, and we can make multiple devlog videos on this. Now, if they don't approve it, well, it's gonna be something that's gonna still be continued on my on myself, even though it might not be used in production. That don't have a direct, let's say, customer for this product. This is a web server. This is a web server that I'm developing that's going to be completely written in C++. The idea is that you can script this web server later on with Angel script, and then things like database migrations, migrating data from one version to the other one, having multiple instances running of the server, having to distribute which server is going to take on a task and things like that. All of this shall be extracted away and computed in the C++ runtime, and the scripting shall be really lightweight, really simple. Maybe we're going to add templates later on as well, like a template engine, so that you basically just define the web content and not everything that happens in behind. The data storage shall be handled later on, also file storage, everything that's fancy, that's complicated, that people build stacks around, that people build frameworks. That's everything that shall be abstracted away, but in such a uniform way that you can really plug in everything that you want. In general, I'm just going to have one implementation first and later on plug in different ones if they are needed. But the general idea is this shall be the solution to build web apps. Now, web apps and C++, I already have a video on that on my channel where I kind of presented a stack. This stack is actually not used. I'm completely developing a new stack. Why do I do that? Because, well, the other stacks were kind of good, but they didn't fit at the end. I have the problem that HTTP parsing and stuff like that was not handled in the way that I like it, in the way that I like to have my control over the system. So I implemented my own one, and in this video, I'm gonna go into and explain you how the web server stuff works. We have a hell of a lot of stuff going on with custom allocators. I've put it say a day of work now into implementing custom memory allocators, implementing custom memory allocations for the standard library, abstracting away the standard library to my custom memory allocators, even have memory tracking in there, which is actually tracking all allocations, which can hunt down memory leaks and fix them. asterisk if, of course, every allocation uses this allocator. But the general idea is, right, we are writing in web server that shall have different configurations like development and release, that I want to be able to track down memory issues in development, so that I can see if there's a memory leak. I might evaluate if I want to actually use this in production as well. This depends on how the performance is of the memory tracking and the whole library in the end, the whole framework in the end. And if it's fast enough, I'm going to leave in memory tracking for the the production server as well. But that's a different story of the next video. So let's get started, take a look on how to implement a web server. Now, it's currently not a web server, that's something that I can already tell you, but how to implement TCP and TLS connections. So, right, if you're writing a web server, you need to support two things, HTTP and HTTPS. It's the same protocol, same story. The payload that's processed by the web server is the same. However, the way the connection is established is a different one, because HTTPS uses TLS encryption to make the connection secure, while HTTP is a plain text connection that everybody in the middle can read. So what we need to do is we need to find a way to abstract this away. Well, ASIO is providing that. ASIO is providing a SSL context and SSL connections on top of OpenSSL, so we don't really need to implement the handshakes on ourselves, but we need to configure it. And the main problem is I want to have a uniform pipeline. I want to have a uniform way of defining how the connections work. I don't want to write my code twice. I don't want to make it quite complicated. I want to have one endpoint that's always configured the same, and I want to be able to plug in an SSL context as ever as I want. Now, how did I implement that? Well, if we're taking a look at the web server, that's some old deprecated stuff that's later on going to be moved into the server itself or removed completely. That's something that I started off with, and then I thought, all right, this is not the way to do it. Now, the modern stuff is inside of the server folder. Instead of here, we have TCP, which is the basic TCP connection handling. We have queue, which is basically how sessions are going to be queued. So as soon as kind of like the handshake is done, if it is a TCP handshake, it's not really much that's been done. As soon as this is TCP handshake or this TLS handshake, which is actually doing the encryption part, or like talking to each other, hey, this is me, this is the server, do you trust me? Yes, I trust you. Okay, now we have a secure channel. There's like stuff involved on TLS. It's not as simple as I told you, but there's some stuff associated, some back and forth between the client and the server until the kind of like secure session is initiated. And basically what I want to do is I want to have a uniform way of storing that. So basically every session that a TLS endpoint, which is how not a TLS endpoint, a TCP endpoint, because in the end TLS is on top of TCP, so it's still like TCP. So every TCP native or TLS session is kind of like registered. As soon as it comes to the endpoint, the session is created, all handshakes are done, the session is ready for the data, for like sending the HTTP request and retrieving the or receiving the HTTP response. As soon as this is ready, they need to be kind of like put it on a queue until a worker comes and actually serve the sessions. Because actually we have a quite of the different concept here, right? It's not as simple as it seems, right? We can completely work with ASIO. ASIO is an async protocol, and in general, you could kind of like wrap everything around ASIO. So you could just use ASIO. You can use ASIO to kind of like create timers that expires at some point to kind of like do cron jobs and repetitive tasks. You can do all like async operations completely with ASIO and just work with ASIO and have one like context run, which is kind of like the function to run and all like pending ASIO operations, and have everything controlled through ASIO. But that's not how I want it. I want to have it decoupled. I want to have ASIO, that's just the IO part, and I want to have my own system of workers that are kind of like doing the work. And actually one of the workers is going to serve the ASIO context, or multiple workers are serving the ASIO context, so that we have multiple threads that handle ASIO IO operations. So we have kind of like a bit of a complex system. So we need to decouple this. The decoupling stage are the queues. And we also have an HTTP folder that's not populated. So if I make a video on top of that, at some point we're going to talk about what I have put inside of the HTTP folder. Now, how do I handle like the TCP sessions? Let's first start and take a look at the general interface so that you know what we're talking with. We have a main function. The main function is actually quite simple. We are using argparse here for argument parsing. I did not put this in here. This is like how it should be copyrighted, because I didn't intentionally know how I want to make the copyright, but I do have my minds up on how copyright's going to work on the software, so this is going to be copyright of my company. So basically what it works is we are setting up the arguments, and then we are parsing the arguments, and if the arguments have been parsed, they gotta go into the args main, and we have a bit of an exception catching around of that to catch pending exceptions. Now the args main function is basically responsible for, this is basically the main function, right? It's responsible for the application flow. Everything in main is just a boilerplate code that calls args main. Now args main internally does a few things. It sets up SPD log and retrieves the default allocator, more on allocators and the default allocator in the next video, and then it starts the async server operations, which is basically this piece of code. So the first thing that I'm creating is the SEO IO context. The IO context is required for all operations, like all async operations are kind of like enqueued on the context, and if the context is served, it kind of like pushes the async operations that are enqueued, and then if an async operation is like finished, it calls the callback that is associated with that request. So basically everything that's handled with like SEO, as well the work that SEO does, as well as calling the callbacks when the SEO work is done, is like handled in this IO context. This IO context is actually quite a nice thing. You can actually call run, or actually process this IO context from multiple threads. So basically SEO scales however you want. You have one context, and every thread just says, hey, I want to work with you, and if work is possible, it's put to the thread, or kind of like put out of the context queue into the execution state and processed by the thread in a thread safe way. It's actually quite a remarkable thing. It doesn't require parameters. You just have one, and then you kind of like serve it however you like and however you fits. Now, what I'm then doing is I'm creating a session queue. We can take it, look at the implementation later. Just going to quickly go over the interface. The session queue is, in general, as I told you, just a queue of sessions. It requires the allocator, because, of course, if it is a queue, it needs to allocate like the slots of the queue. It's basically like a list, a DQ, however you want to implement this in C++, or however the standard library implements that. It requires memory allocation, so I'm going to plug in my default allocator. Then I'm going to set up some SSL parameters for SEO. This is done with the SEO SSL context. This is a TLS v1.3 server. I think this is the latest version. Not too sure about that, but I think it is. Yes, it is. You can see like the versions. SSL is like the old things. It's still like called SSL HTTPS often, but SSL is old. You don't want to kind of like use SSL these days. You're always going to use TLS. And in this case, we are taking the latest version, which we in general should do. In this case, it's 1.3, and we are a server. So we initialize this context to be a TLS 1.3 server. After we have done that, we need to configure the context, which is happening here. We are using a certificate chain file. This is kind of like the identity of the server, which is the public key, the key that's distributed to the client to say this is the server, this is how you communicate with me. Public key, yeah, it's a public one. This is the one that you get if you're buying an SSL certificate. You get a private key as well, but if you're buying an SSL certificate, you're going to get a public and a private key. Most of the time it is PEM formats or other formats. You can convert them around however you like. Now these certificates have just been generated here. So if I take a look at the app directory, maybe we can make it bigger, or let's just reveal this in the file explorer. If I am at the directory, you can actually see these are just some key files. I've generated them. It's not a big deal. Basically, you can find web pages online that generate you these certificates. You can figure out how to enter the OpenSSL command to generate the certificates on your own. I'm just tending to not remember command line arguments and just use some online services that just spills me out these certificates. One thing that's really important, these are not safe. if you want to have a cheap certificate, you're going to later on use Let's Encrypt. Let's Encrypt is something that you can install as a service on your Linux machine, and Let's Encrypt will basically generate a certificate for you. It will do that by contacting their secure server. You're going to give them your details, like email address and the domain that you are using, and then they will generate you a certificate for free. And they actually have something called certbot that is also making sure that these certificates stay up to date and is automatically updating them if they would expire. Now, as I told you, are going to get a public and a private key. Yeah, used for encryption. I don't want to go. I'm already too much into the details on how encryption works without really giving you some valuable information. I'm just going to give you the valuable information, what you need to actually use them, but not on how to understand how it works. Now, in general, public key, this is the identity of the server. This is validating that you are the owner of the domain. Now, these Let's Encrypt certificates are not very strong. If you want to do something like an online shop or like a web page where users actually sign up and put in their personal details, you want to give for a better certificate that is like more trusted, let's put it like that, that has like at least like something like maybe even organization validated information in here, depending on how far you want to go and how far the requirements are. Now, the public key, it's the identification. It tells who owns the server, and it also associates a key that the clients can use to know that they are sending the data to this server. Now, what we have is the private key file. The private key file, as it tells, is private. If this one is leaked, your whole certificate needs to be revoked and removed from the internet, because if this one leaks, bad things happen, because everyone can pretend that they are you, that they are the server. Now, if this is leaked, if some bad hacker has the certificate, the private key, they can pretend to be your server and lure your clients into, hey, you're on the right page, enter your banking account details because we need payment. They enter it and they completely stash the whole money from the customers of yours. So that's a really important thing. Don't leak them. I could leak them now because I have these self-signed things. Hey, this is my private key. Now you can impersonate to be my self-signed server. This is why I should never show this on video, right? But what I'm using is not secure. This is a development environment. This is like the big where every web browser tells you, oh, the certificate is not trusted. Do you really want to go and go further and connect to that server? Yes, you want. This is something that they just use for development. I can generate this with a finger snap by just typing in the address into Google and find the right page that generates me a certificate, or by asking ChatGPT to give me the command for OpenSSL. But yeah, in general, you should not leak them. Now, down here, what I'm doing is I'm setting options. These are a few things that you do. This one is required, a single DH use. I'm not really have dig down into what it is or why it's required. Sorry for that. What I'm then doing is I'm disabling SSL version 2. This is like a deprecated version. In general, the ASIO SSL context is backwards compatible. So if the client advertises that it has like TLS 1.2, communication is still possible. The server will kind of like downgrade itself to TLS 1.2. However, what we are telling them is no SSL v2, because this is like unsecure. So we tell the context, hey, you shall not downgrade further than like what comes after SSL v2. So every SSL v2 and SSL v1 will not be possible with this server. Now, in general, there are something called workarounds. I'm not quite sure if they are described somewhere. They should be described somewhere. However, in general, there are a few workarounds that make the server work more reliable and also more stable, and actually I think even faster. Not sure. These are like workarounds that just make it more stable. It's not like 100% to spec, but this is something that's commonly done to kind of like fix the server to work better. Now, if I describe this SSL context, it allows me to now use it for SSL communications. And this is what I'm now doing down here. Down here, I'm describing now my server or my TCP endpoint. It is a server, but in general, it's actually a TCP endpoint. It's the endpoint on the server that's accepting connections. Now, this also requires an allocator, because this is later on going to allocate sessions. This is also using some internal like allocations. So it's really important that it has an allocator and basically knows how to allocate memory with the library. Now, first of all, what I'm going to tell the server is its IP address. I'm telling it the IP address by making an address out of a string. This is kind of like the local loopback address. So, or not, I don't think it's loopback. Is it loopback? I don't know. I'm too much out of that IT stuff, infrastructure stuff. Basically, this is the address of your computer that never changes, right? If I go to like CMD and do like IP config, I'm gonna get the IP address of my computer, and you can actually see Ethernet adapter. My computer has the IP address 172.16.1.100 on the 255.255.255.0 subnet. This is the IP address. If I would take that one and place it in here, the server would still work, because now it's the IP address of my computer. However, this is something that you would not commit to Git, because everybody has a different IP address. This IP address is not something that you're going to have. You're going to have something like 192.168 or what? 186? No, I think 168. Like, this is an IP address that you're going to probably have, because this is what a Fritzbox and like ISP routers does. This is a very special address that I'm using here, and yeah, basically this one is a universal available address. However, this means that it's only accessible from the current computer. If I take that address, everybody else in my network can reach that web page. If I do it like that, it's only working on my computer. But this is like the portable way of doing it, and if you are on a development ecosystem, you should do it. If you're on a production, you need to, of course, find out the correct IP address on your machine. If you are on a production server on the internet, you probably have a load balancer or a firewall in front of you. So you have your internal IP address in here, and then the firewall does the remapping to the public IP address, or the load balancer does the remapping. Now, down here, I'm now specifying the port. The port is kind of like the TCP port where it's reachable. The default for HTTPS is 443. Then I set the IO context. Since this is an async stuff, it needs to work on an SEO IO context. And since I want to use encryption, I'm going to set a SSL context. Now, this server is generating sessions. How to deal with the sessions is described here. So first of all, I tell the server which kind of sessions it shall use. In this case, I want to have a TLS session. I could also have a TCP session. If I use a TCP session, it is unsecure. It's no longer encrypted. If I use a TLS session, now it's encrypted, and then only if this is a TLS session, it will consume the SSL context. The next thing that I'm specifying is the queue, so where to put the sessions that have been correctly connected and handshaked with the server and are now ready to process data. Now, the last thing that I'm doing with the server is I'm going to call start on the server, which basically means, hey, now open the connection based, or open the server, open the endpoint based on these parameters, and kind of like start accepting connections. Then in a while true loop, I'm just gonna serve the context. So I'm just gonna run the context once, and I'm clearing the sessions. Since I'm currently not processing the sessions, I'm just gonna clear them. And by clearing, this basically means closing every open session, which basically means disconnecting all the clients and directly closing it. Now, this is basically how it looks from the outside. How does it work in the end? If I run that code, well, I changed stuff, so it's recompiling. Did I change so much? What did I change that it recompiles everything? Huh. Interesting. Yeah, okay, but it should be quite fast, right? What did I change? I don't know. Like main, actually. Now you can see now if I start it, I'm gonna get a bit of an output. So first of all, the logging subsystem is initialized, which means that I'm gonna getting custom log formats, names of the loggers, and actually even different set up loggers. And now it tells me that it started a TCP server on that port. And if I now try to connect, so if I open up a new Firefox window and go to HTTPS localhost, well, I'm gonna get that page. Gesicherte Verbindung fehlgeschlagen, which means secure connection failed. Beim Verbinden mit localhost trat ein Fehler auf. While connecting to localhost, error arised. PR connect reset error. Error code PR connect reset. So the connection resetted. I'm not quite sure what PR means. If this is post. Not sure. Let's find out what this means. Mozilla support. No, it's a question. I don't know. I would love to know what PR means, but I don't know if this is has something special meaning, but I don't know. You can basically see that connection failed. If I take a look at the console, we can actually see that we get a hell of a lot of logging messages. So first of all, you can see a TLS session has been created. It has started the TLS handshake, and then down here it has closed the session. You can see that's this session because this kind of like the port where the session was established. You can actually see you can see begin the TLS handshake was successful. You can see session created, beginning handshake successful, closing. Then you can see that we are getting a next session is also doing handshake. Basically, Firefox tried to reach our web page multiple times. That's kind of like the story. You can actually see that this is nicht sicher, which means not safe, and maybe I can force Firefox to no longer trust me, but basically I once told Firefox that it shall trust us. But you can see that it actually detected that certificate. It detected the certificate even through we are not going to get any web page content, which means that the TLS handshake has happened. We are connected. And you can see that we don't get any informations at all. It's like all not provided. We don't really have a certificate. We do have a public key. We do know how to secure communicate with the server, but we cannot validate the certificate. This is basically what this is telling us. And also if I take a look at the informations, there's no information. I can't see anything which basically says, well, they could not validate the peer, but the connection is secured. Now, let's take a look on how this all works under the hood. Now, how do we go for that? Now, let's first start at the TCP endpoint. How does the TCP endpoint work? Let's first quickly step over all the odd stuff and take a look at them as soon as they work. Basically, what I wanted to implement a non-templated class which allows a templated type for session creation, if that makes sense. Which is normally people would just go with a template argument of the session, but I'm crazy, so I do it differently. Is there a point? Yeah, maybe there's a point. It makes it a bit easier. It doesn't mean that in the end it doesn't matter, but I'm just getting my way around of making the whole class templated. Which means that it's a bit easier to pass the endpoint on and later on also use the endpoint in a web server and allow the web server to serve the endpoint, which was the initial thought of doing it like that. But then I came up with the session queue, and now the session queue kind of like makes this concept obsolete, but it was implemented, so why change it? All right, so the first thing, a TCP endpoint requires a basic allocator to work. We have a few functions that basically just set the parameters. You can see the IO context is stored as a pointer, the SSL context is stored as a pointer, the IP address is stored in an SEO endpoint, the port is stored in the SEO endpoint, the session queue is stored in the pointer, and that's basically it. This function is a bit more interesting. How do we actually provide the session class? First of all, we have a template parameter. What I am doing is I'm creating a so-called session creator. The session creator is basically a STD function which takes a queuable session. So the queuable, maybe I should have, probably this one supports custom allocators as well. No, it does not actually. Okay, so we have an STD function. In this case, it's a function that returns a so-called queuable session. So a session that can be queued. Basically, a queuable session just has the message sent with a session queue, where it shall enqueue itself as soon as it kind of like finished the start operation. There's a send function, a receive function, and a close function. So you can send data and you can receive data on the session, and you can close the session. Now, what we are also serving is a transfer state for the send and receive state. The transfer state in general is just very simple. We can have a non-transfer state, which basically means, well, nothing has been done. You have an in progress state, so it's currently transferring something. It has failed and succeeded depending on what happened during transfer, and you can receive this for sending and receiving. Then I also have the option to access the local and remote endpoint. The local endpoint is the server, and the remote endpoint is the client that's connected to the server. Now, there are multiple implementations available for this queuable session, the TCP session and the TLS session. But let's first continue on with the endpoint. In general, this create session is just kind of like a STD functional for a function that creates a session. Now, how do we create a session? Well, we do it like that. We create this by providing a socket that's kind of like just connected to the server, a SSL context, a pointer, which is optional, so that we can do handshakes if we want, and a logger that's basically just passed onto the session. How do we go for it? Well, we provide the allocator associated with this class. We move in the socket, so the socket that has been kind of like connected to the endpoint, we move it to the session, and we then pass in the other parameters as well. Now, how do we work with the server as well? We have a start and a stop function. The start function basically just starts accepting connections, and the stop function stops accepting connections. Now, we have internally a begin accept method and a on connect method. The begin accept basically tells ASIO that we are ready to receive a new connection, and as soon as ASIO has a new connection, it calls the on connect method, which gives us an error code, which indicates if there was a failure, and it gives us a socket of the peer that connected to us. Internally, well, we just have a few fancy stuff, and we have a unique pointer of an acceptor, which is a TCP acceptor, which is basically the server, not the actual server, right? Yeah. Now, how do we do and how do we roll? So if we are calling start, basically what I'm doing is I am using std make unique, which is not what we should do. We should use the allocator. So there's a make unique function on the allocator. What the hell? Context dereferenced. It probably requires a reference, std reference wrapper of the context. Now it works, and an endpoint. So this is basically the idea. The acceptors constructor requires a ASIO IO context, and it requires an endpoint. The endpoint is constructed with the address and the port in the header. We already take a look at that, and we just reference wrap the context in here, and we are using make unique of the allocator. Basically, we gotta get to that in the next video. I built something into that allocator that basically works like the standard library, and since this is abstracted, this is CPP STD. CPP STD is my wrapper. I have my own unique pointer, which is basically just an STD unique pointer with a different deleter. That's the big important thing there. It's a different deleter. Actually, previously it worked because I am with my default allocator at some point going to malloc in free, which is how every memory allocation works, and they're doing everything on my own. This is why we didn't have issues previously. Now, after we have the acceptor, we can begin accept. Begin accept basically means that we want to handle an async accept request and bind the onConnect function with functional placeholders. And after that, I'm just going to do a bit of logging, and I'm also do a bit of checkings that the acceptor is now really in existence. Stop works similar. The acceptor is closed, the acceptor is cleared, and we're doing some logging. Now, what happens if we are getting a connection? So first of all, if we have an error in the error code, we basically gotta kind of like fail to accept TCP connection with the category name and the message here. Don't know if we really need that, but I've put it in here. And then we are going into the else part. Now, first I'm doing a bit of validations. First of all, I'm checking if the session creator is not existing. If the session creator is not existing, I'm logging an error. If the session queue is not existing, I'm logging an error that there's something going wrong. And then if both of these are in existence, I'm creating a session. Now, currently you can see that the session is checked for failure. We don't need this anymore because my allocators, they always allocate. If they don't allocate, they throw. It's like it is. You could argue that's not a good idea, but still, yeah, that's how it goes. Now, in general, I'm just creating a session with my sessions creator. I need the allocator. No, I don't need the allocator in here because the allocator is implemented in, come on, is implemented in here. It forwards the allocator like this. So it's good if you know your own code, but yeah. And then what we do, we just start the session with the session key, and then the session will do everything on its own. And this seems odd because the session creator actually, which is the TCP session creator function, basically uses the allocator to create a new object, which is like similar to the new keyword in C++, or basically that's exactly the same than the new keyword in C++. And if you're using the new keyword in C++, it means that you need to at some point call delete. Now this seems quite odd that we are kind of like starting the session, or we are creating a session pointer, and we are starting the session and we are releasing all references to this pointer. However, start will enqueue itself at some point to the session queue, and it will enqueue itself. So the session will enqueue with this pointer, which means that at some point the session is owned by the queue, and the queue makes sure to call close on the session, which on the session, in the session code itself, calls delete on the sys pointer with the appropriate allocator, which has been passed via the msession creator, which is coming from this class. And this means that everything is good, because everything else is handled by ASIO. So if we are starting the session, it's either enqueued directly and awaiting operations, or it's doing a async handshake, which at some point, we're going to get to that code later, calls the callback in the session with the sys pointer, which can then decide if it wants to enqueue or destroy itself. That's how ASIO works. That's quite odd. It depends that you wrap your head around that. ASIO uses sometimes some fancy stuff like having a shared pointer and using this pointer to add a reference on the shared pointer, and then they are using lambdas, and as long as the lambda is in existence, the reference count is not decremented, but when the lambda kind of like finishes calling, it gets kind of like auto memory managed. I do not trust these things. I mean, they are implemented by the standard and you could trust them, but I find it even more hard to get your head around than just having like this strict, there's a session created, the session manages its own memory, and in a deterministic way, the session either destroys itself or gives, actually it does not even give the memory ownership to the session. The session always owns the sys pointer. And this is where we now jump to the TCP sessions. You already know the interface. There's nothing fancy around that. The only thing is that we have the ASIO send and receive events in here and just have a bit of an instance of the stuff. But in general, a TCP session, when it's created, it just queries its endpoint. It does tracing. If there is an SSL context for a TCP session, it does a error or warning. It does a warning that you kind of like implicitly tried to create a secure session with a non-secure, or that you tried to describe a secure endpoint with a non-secure session, so it warns you. This is nothing that should happen. This is just for me, the stupid developer behind everything, to know what happens. Now, destructor is simple, just close the socket. When we are starting the session, if it is a normal TCP session, we directly enqueue it. There's no handshaking involved, we directly enqueue it, everything is good. Now, what the queue does, the queue would call maybe close at the point. Where is close? Now I had it somewhere here. You can actually see I'm now calling delete on this. And this is basically where this is the point where sessions are deleted on the close method. The close method will at some point always be called and delete everything. Everything else is just some boilerplate code around. Like sending, just some ASIO abuse. With placeholders and binding to the ASIO send event, doing some state checkings, tracing if we are actually sending, warning if it's the wrong state. Actually, we are throwing, so there should be actually either more be like an error. No, why I see this as a warning, so this should be more or less an error. And then we are throwing. This works for receive the same. It's like completely the same, just that we are kind of like also for receiving, sending pointers to our callbacks as well. I don't know why I'm even doing this, right? I'm doing this because of logging. Yeah, that was something. And or do I? No, I don't even log the memory pointers at all. So I could also have ditched that. But there, it's in there. I thought I initially had also different plans for that class. As it evolved quite a bit. It's the first time that I'm implementing like a TCP TLS independent HTTP server in C++ without a library. So yeah, just don't blame me if there's something that not seems like it should be. Right, so the events itself, they just do like state transitions to failed or succeeded and log what happens, warning if something failed. Should this be an error? We are not throwing, so one should be sufficient then, and then later on there could be an error on top of that, but yeah, should it be an error? Ah, come on, let's make it an error, right? We can use errors, it's nice. It's good. Now, basically, it's just some boilerplate code around ASIO to store the state and just make it a bit more accessible and basically allow a worker thread to kind of like query the states and to also send and receive data. There's going to be messaging involved later on. I'm going to later on implement messaging that basically tasks can put on a blocked queue. Maybe this is not going to be a queue at all. Maybe this is going to be free floating. And out of this, let's say tasks can be later on put on a block state. And as soon as kind of like this IO operations are finished, they are putting on the kind of like schedulable queue, and then Fiber can work with them. I'm trying to implement a job system, a proper job system on this. I don't know if it's a good idea to implement this on the web server. We're gonna see at the end if the scheduling overhead is worth, or if we're just gonna have threads. I do think that a Fiber system is good and the proper task scheduler, because I also want to have like cron jobs. I also want to have actually worker jobs. So, for example, there's going to be at some point PDF creation involved. Not sure if I can even do this with C++, but even if I just use Boost to kind of like do it or write my own stuff. I mean, in the end, I probably also can just generate like a LaTeX script and just run an async LaTeX process to kind of like generate me the PDF, but in the end it doesn't matter how it's going to be implemented. I don't think that there are like good PDF libraries for C++. There are some. I need to evaluate this, but yeah. I do want to have actually like worker threads and all of this. And if we have like a scheduler, we can actually assign them priorities and implement this on our own. I mean, you can probably also modify this and make this completely with C++. And OS APIs like POSIX thread and Win API. However, I think that's worth implementing it on our own. I mean, there are other products like game engines that do that because, well, it's most of the time better. We can have finer controller if it's in our application, don't need to rely on like OS scheduling. So we can just say, all right, how many cores does the machine have? All right, spawn that many threads and then convert them to fibers and then hustle through some queues. I'm completely off topic now again, but yeah. You're gonna get some value out of that video, hopefully. Just a bit of engineering talk, dev talk. I'm now ending up going line by line over the code, so don't steal it. It's my copyright. Can sue you if you steal it. It's not. It's currently, it is released under you don't use it. Like one by one. If you implement the concepts, I probably can't do anything against that. But I'm not sure how this is gonna be licensed. It's probably at the end, like the chance is 70% that it's going to be completely open source, but maybe not under a permissive license. That depends on how I want to argue. Because I do have a company now that runs a YouTube channel, and I do not have anything against people using that for their hobby projects, for non-profits, for learning, for everything, accessing the source code. But like proper companies that make a ton of shit of money if the server works, then yeah, I don't want to like shoot myself in the foot so that I don't get any benefits out of that. But yeah. So this is the TCP session. Now, how does TLS look like? Well, basically, it's also just some wrap around ASIO. The only difference, like send, receive, close, send state, receive state, endpoint, events, work completely the same. This is also why I need to adjust the log levels now. These are now errors, and there we are. The only thing that really is different is actually the start method. Everything else should be the same. The only thing is that I'm not shutting down the socket because if the handshake failed, this doesn't work. So yeah. The only thing that's different is now this the start method. Now, first of all, I'm now logging that I'm beginning the handshake, and then I'm doing as a handshake. I am doing this with the server, and I don't know. I've gone for the lambda here because it's kind of like the handshake. I didn't want to populate this too much or to pollute these. So if I later on change something on the other class, I can just copy paste the bodies in here, so that everything works fine. I could also have gone and used the TCP sessions and just make the other one virtual and override this again. In the end, this might have been the better call because everything else is like, except like the constructor, it's like completely as is. So yeah, the only thing, the difference is kind of like the members. This one has like the SSL member and this one not. So yeah, it's better to have these separate. Trust me, it's not that much of a code. There's gonna be at some point like this messaging between the kind of like ASIO worker and the ASIO IO task and the task that's actually like using this to send and receive data. There's gonna be some messaging going on between these, maybe, if the kind of like worker is producing faster than the session can send. But there's not much that I'm gonna add. So these are actually gonna be very simple. Now, basically, this is the only thing that you need to do. You need to tell ASIO that you want to do a handshake, that you want to do it as a server, and then you just provide the function if it's finished. And you're gonna get an error code, and the error code indicates what happened. Now, in general, handshakes can be normal. Actually, I think that I do want to put this one as a debug message, because this might be something that you want to catch on a production system, but it's not a development only thing. Now, in general, it is normal for connections to fail. For example, if the Firefox browser does not trust the server, like what happens with self-signed certificates, which I don't get because I already trusted it. But normally, if you're connecting to a server that's non-secure, like this one suggests, and if you're doing it, it will first throw an error and then the handshake fails, and we are getting into that section, and it basically just says that it was not trusted and the connection needs to be closed, and then I'm calling this close, which again deletes itself. Else, if I was successful, I can enqueue myself, and at this point we now have on our queue sessions that are ready for data. If it's a TLS session, we have a handshake done. If it is a TCP session, well, it has just been created and put on the queue. Now, how did I implement the queue? Well, queue is quite simple. It is a STD queue. Now, CPP STD is just my alias, but just don't think, just put that out of your mind. This and this is exactly the same. The only difference is the initialization. The CPP STD queue cannot be initialized like a normal queue. You can use my helper called queueInit, which requires an allocator, and then it's going to initialize the queue with the allocator so that the allocator is used for all allocations. And yeah, that's basically how it is. We have a clear function to clear the queue. We can check if we have sessions. We can enqueue a session, and we can pop a session to kind of like work with it. That's the idea of the queue, right? You pop the session, then you are in control of the session. And basically what will happen is that a worker thread will basically come and take a look at and say, all right, is there a session available? Yes, then pop it. Or I think the pop also can return null pointer as far as I'm concerned. So you're popping a session, you're getting a null pointer. You know that you kind of like need to go to sleep or work on different things. We might in the end also go on with messaging. So there's also maybe some messaging that's going to happen. So there's maybe some messaging in the future going on that we are getting kind of like notified on the scheduler. Hey, we have a session in queued, launch a task that is gonna proceed the session. So every time a session is created, we kind of like tell the scheduler, schedule a new one, schedule a new one, schedule a new one, and then they're gonna pop off the queue as soon as they are ready to actually start their work. So there's something gonna go on as well in the future, and then they want to pop off the sessions from the queue and use them. Now the session uses a spin lock to kind of like manage concurrency. This is maybe something that we can also do. Maybe we're going to take a look at the async primitives in the future as well. They are kind of minimalistic currently. There's not much going on. It's a basic spin lock with like test and set and clear. There's a lock guard that basically just automatically acquires the spin lock. The only fancy thing that's really going on here is that you can over-engineer this as well, that you can actually try acquire with timeouts, pause functions, Boolean pause functions and stuff like that. The pause functions are actually important later on because we might want to run other tasks. So there's going to be a default pause function that's going to be supplied via a macro that you're always going to use if you are using like a lock guard or like a spin lock and you're locking a lock, or you're trying to acquire a lock. If you're not just polling, if you can acquire, if you really are waiting for the lock, you provide the pause function. The pause function is going to handle task swapping, which is something that you need to take in mind. So if you are writing performance systems, and something like this is common that can happen, this uses atomic these locks, so they are blazing fast. But you need to also make sure that your tasks are not blocking. Because later on, if you have a certain amount of worker threads and you have a certain amount of tasks, if you have like 8 worker threads and 8 tasks are blocking, then you're not going to get forward. So you need a way to do it. This is also why it's sadly no longer available in Windows. I think there is something on Linux, but only I think with the real-time kernel. But not 100% sure about that. That's kind of like called user mode scheduling. Basically, it allows you to customize the scheduler to kind of like avoid these situations with like, so you can use threads, but have them as fine control as implementing your own stuff. Now, this is something that they need to be careful, and that's something that's going to be handled by the task system. There's always going to be a guaranteed amount of workers that are free for certain systems. So there's a worker always going to be free for ASIO. There's a worker always going to be for actual session processing, and the other ones are probably going to be flexible. Of course, it's going to be configurable, but the idea is basically that ASIO never locks up, so that you're always going to be having a thread that can provide and do I/O work. You're always going to have threads that can actually like process the sessions, and then everything else is not as critical. Because like these are like the main failure points. The ASIO shall always be responsible. These are kind of like the main blockers is going to be I/O, especially if you're doing stuff like that. We're going to always have deterministic behaviors on the other ones. So as soon as we're getting to like user codes and having like a VM execute stuff, this is also going to be handled in own tasks, like running the AngelScript VMs for a call. So if something goes wrong and wrong there, we kind of like still have a backup there, and then we can in theory kill threads that are unresponsive. Asterisk, if we know which task is on the thread, and we can safely terminate the task, and that's the whole idea. The whole idea is here to build a safe web server that can basically on a deterministic way say, yeah, that thread has an issue, it's deadlocked, it's only using memory for that session. I'm going to drop the whole session, including all the memory. I'm cleaning up all the memory the session owned. I'm closing the thread that was working on it. I can really, in a deterministic way, stop a hung session without the whole web server going down, because this is what you need to take care of if you're trying to write business class grade software. So, yeah. Basically, this is the lock itself. It has a bit of abstraction around locks, and I do do a hell of a lot of template shit in here. I don't want to go too much into the detail, but a spin log is a log with the spin log base, and the spin log base is basically just on simple try, acquire, and release, because this is what a log needs to be able to do. It needs to be acquirable and releasable. Everything, or try acquirable and releasable, everything else can be implemented in the log, no matter what's really happening, right? Like a querying with a pause function, try acquire with a timeout, try acquire with a boolean pause function, and like everything that can like block and is not independent, is independent of the implementation of the log, can be kind of like abstracted away. And the log guard as well. Like this is also something that's then based on a log, and the actual log that I'm using in a log guard is, well, basically in the end we are using a log guard of a log of a spin log base, which makes it seem complicated and makes it seem very like a same level of bullshittiness than the template library, which nobody understands, but in the end it makes sense to write software like that, even if nobody understands that if you're into the topic. But yeah, I think that's it for the log. Let's jump back into the queue. Now, in general, the implementation is, I don't need to show you how a queue works, right? If we are closing it, just clear it. If we are clearing it, well, make sure that we are the only thread working on this. As long as we have sessions, give me the session, close the session, pop the session. And queuing the session, simple. Just one thread can do that, push it. Pop a session, simple, just one thread can do that. We have the session pointer that can be returned to null pointer. If we have a session, get it, pop it. And actually, if we want to even squeeze more out of it, which we probably, memory barriers, I know, makes it even more performant. Critical section is only starting here, right? You can take the pointer and set it to null, clear the register before you're going into that, right? So yeah, but in the end, the compiler does optimize stuff like that. But it always makes sense if you're trying to write performant code to kind of like say, okay, begin of critical section is as soon as we get access the queue. And actually, thinking about that, actually, nah, this should be here. Definitely should be here, because either we're gonna have a deadlock there. This is how we need to check, we need to log, check, and then we can go on. This is also why checking is not thread safe, because I was not bothered yet to implement a routine and log. Which is probably better, because a routine and log is something that we then need to implement for like a fiber routine and log and a thread routine and log, and it's gonna involve a bit of more shit around it. But yeah, plain simple queue. I don't need to tell you how queues work. Yeah, and if this all comes together, well, you have sessions that don't do anything, right? Too much bullshit around something that doesn't do work. And the video is way too long. However, that's what it is. I'm gonna do another video about the memory management. And I'm gonna hustle tomorrow to make sure this is all gonna be edited, and I'm gonna make sure that it's gonna be uploaded. I stupidly did not make a backup of my DaVinci Resolve project database, but I do have an old one somewhere laying around. But I think it's also not too big of a deal to just find the two corresponding files in the file system, right? Oh no, I think music was on the no, music is separate. But do I have music on my disk? Nobody knows. I think my pictures. No, I don't have access to my intro. But I see. I gotta see how I gonna edit them. Maybe you're gonna get the video without an intro. I don't know. But thank you for watching. See you in the next video. Make sure to like and subscribe, and have nice holidays, nice Christmas, and it's already finished, right? A nice new year. I don't know what I'm talking about. But yeah. Bye.